of cooking and some art. So when you cook food, what is food? In elementary school, maybe kindergarten, you learn about the states of matter. You have solid, liquid, and gas. Then you get higher up, they tell you plasma, so it sounds cool. But then you get to Jello. What's happening there? It's squiggly like liquid, but then it stays solid, but it's transparent. Like, what is that? So in physics, we call that soft matter. What defines a soft material? A soft material is defined as something with a large response function. Basically, you apply small force, but the object has really big change to it. So think about, say, whipped cream. You poke it a little bit, but it spreads a lot. Or mayonnaise. When you squeeze it out, it's a solid. It stays there, but you can spread it easily. Same for other food, like steak. It's solid, but you can definitely cut it and chew it, right? So most food we eat is soft matter. And we can quantify that softness by a modulus. Basically, you apply a stress to the material and measure the strain, like how much it deformed, and we call that a modulus. So there's another way of thinking about the modulus is energy density. So let's say you have a block of crystal, right? What's the relevant characteristic length in that crystal? It's the atoms, the width between the atoms, right? And the relevant energy is the atomic attraction. So it's really big energy over really small space. So you have a big modulus. So it's really hard to deform. But if you have, let's say, shaving cream, the characteristic length will be the size of the bubbles. So really big. But the energy attraction will be a little bit weaker. So you have little energy over really big length. So you have a smaller modulus. So that's why shaving cream can deform easily. And with food, we play with everything. You have solid, like candy. You have liquid. I hope you guys drink water. Complex food, like oil is no, not oil. Well, most gel is a complex food. Foam, like whipping cream. And colloid, like milk, is a colloidal suspension. Mayonnaise is also a colloidal suspension. And mayonnaise is kind of amazing. You just get egg white and oil, mix it, and bam, mayonnaise. You mix two liquid and you get a solid like material. It's amazing. So how do we cook food? Most way that you cook food is just heat and energy transfer. So that's the heat equation. Change of heat over time equal to alpha times the Laplacian of temperature. What's alpha? Alpha is the thermal diffusivity of the material. It's K over rho Cp. K is the thermal conductivity of the material. Rho is density. Cp is heat capacity of the material. So a lot of it is just heat capacity. But we don't always use heat when we cook. There's also fermentation, like making cheese, making yogurt, alcohol. Whoever came up with alcohol was amazing because you just put grape in a barrel and then you drink it. Like, what? And also
well, don't put
bread.
any benzene.
And sometimes you even eat food raw, like vegetable, fruit, sushi. So let me tell you how heat and energy transfer come into cooking. So in cooking, there are what called reversible change and irreversible change. Let's say you have water, you can cool it, make it ice, or you have ice, you melt it, it becomes water again, or you can steam it and cook food with the steam. But that water is reversible. You can add energy or remove energy from it to change the state of matter. But then you have egg or meat. Once you cook the egg, it will never be raw again. When you cook the meat, it will never be raw again. So, and another thing is when you add energy into water, it goes from solid to liquid to gas. But when you add energy to meat, it goes from soft to solid. You add energy to egg, it goes from very liquid to solid. So what's happening there is the protein in the meat or the egg, they nature at a specific area, specific temperature, and unfold, and that unfolding of protein make the materials harder. And then chocolate. Oh, good. Real quick, real quick.
Yeah, it's Valentine's Day tomorrow.
Yeah, I'm not gonna give a representation on food without actual food. Please share.
We all get this?
No, share, share, share.
That's good.
Share. So what separates good chocolate from amazing chocolate?
This is a good deal.
Really good. Well, what chocolate made of? It basically has this fat molecule that has 6 or 7 different orientations.
Wait, so we can open it?
Yeah.
And eat it?
No. Is that irreversible?
If you eat it, it's not exactly reversible. So chocolate is made of stuff and then this one fat molecule that has 6 different orientations, like it can orient different ways, right? And that's this one specific orientation, number 5, that you really want in chocolate. What happens when you maximize that? So the chocolate will be glossy, it will snap when you break. Apparently people like that. But the most important thing is it's melt in your mouth, but it stays solid at room temperature. So how do you maximize that? The chefs do something called tempering the chocolate. Basically they heat it up at a slow rate and just keep mixing it so that they maximize the fat molecules in the chocolate. Blowing on hot soup. We all know that when the soup is hot, you blow on it, right? But the air in your mouth is warm. How effective is that at cooling soup? Well, you probably found out it's pretty quick. So is it your air that's actually cooling the soup? Actually, no. What you're doing is you're blowing away the vapor above the soup so that the soup is evaporating faster because there's no warm layer of vapor above it. So what you're doing is you're blowing away the vapor, you're not cooling the soup. But you still get the same result. Cream to coffee. This is a fun one. Say you have a friend coming over and you know they don't like black coffee. So you want to add cream to it to be nice, you know, impress the ladies. But do you add the cream before, right before they come? Or just add it right after you make the coffee? If you add it right then, is it going to cool down too much and then when they come, they're going to have cold coffee? Turns out, black coffee evaporates faster than coffee with cream. And due to the law of energy works, when you have black coffee that's really hot, it will cool down faster than just warm coffee with cream in it. So what you want to do is add cream to it. Don't just let it sit. When they come, they'll be amazed at how the coffee is still warm. And then you have the latent process then. If you haven't seen it, it's basically when you drop water on a really hot pan. Some of the water evaporate, but some will form a bead and just roll around. You just point it funny. Same thing with liquid nitrogen. You drop it on the floor, some bead will just roll around. Yay! So why is that? That's because when you pour something really hot, something cold to a really hot surface, some of the liquid instantly change into vapor. And then the liquid will sit on top of that vapor layer and just roll around. In cooking, you don't want that. Let's say you have a piece of frozen steak you just took out of the freezer. Put it on a very hot pan. There will be a layer of vapor between your pan and the steak. You will have uneven heat. You cannot directly control your cooking time. That's really bad. So good chef will wait for the steak to be at room temperature before cooking it. And food safety. This is where a lot of science go into food safety, because bacteria, you don't want to eat bad bacteria. A culture of E. coli within 48 hours will completely fill your plate, your petri dish. But then you also have good bacteria. That's how you make yogurt. And then you have antioxidants you want to take in. Then you have bad and good nutrients like vitamin and then steroid. So a lot of science going into food safety. And then a lot of the heat transfer has to do with heat capacity. So your meat, your chicken, your steak, your pork will all have different heat capacity. You want to take that into account when you cook. Then liquid will, of course, have a different heat capacity. And then your cookware, copper pan is going to have different heat property than a cast iron pan. And then water is amazing. It's in almost everything. It's a very good solvent, and then the phase diagram of water is really whack. In every phase diagram you look up, this slope will be positive. But this slope here for water is negative. I can prove it that using that you can prove that ice has less density than water, but too much time. But water is really whack. It's the only thing with a negative slope right there. Then your cookware, you have pans that you want to, somebody in the past probably got burnt by handling the pan, that's why they add a handle. Then you have pots. There's different property of heat transfer when you have the pot covered and uncovered. When it's covered, you have the vapor trapped inside, so the water will cool, not cool, heat up faster. But sometimes you maybe want the water to evaporate, so you cook uncovered. Then you have oven, which just heat the air, and then the air heat the food. Then you have grill, which is just use the flame. Liquid nitrogen, amazing. And then recently we have what's called sous vide. It's been around since 1970, so pretty recent. 1970 was also when they started making ice cream with liquid nitrogen. So what's sous vide? Sous vide means cooking under vacuum. What they do is they put the food in a vacuum pack plastic bag, put it under water. This water is already heated to the desired temperature. They circulate the water so that all the water in the bath is the same temperature. You put the food in, your food will just reach the temperature. So let's say you're cooking your food with a pan, right? Temperature of the pan will be very high. Temperature of your food will eventually reach thermal equilibrium with the pan. But there's a very short period where the food is raw here, but way overcooked here. So you have to take the food out between here. Same with the oven. But with the sous vide method, the water will be at the exact temperature you want it to. So you have precise control over your food. So with a sous vide, the batt will be here, your food will reach here, but it will be done the entire length here. So a lot of chefs like to use that to have precise control. But yes.
I'm sorry, how is that different from just putting the food directly in water?
In water, you don't have precise temperature control because it's not circulated. In sous vide, they circulate the water, so every single atom in the water bath is the same temperature.
Okay.
So you're getting the isotherms to go close to each other.
Yes. Yeah. And yes.
As far as I've heard, compared to like normal boiling, sous vide temperatures are also very low, correct?
Yes.
Yeah.
So with sous vide, you can cook an egg at 63 degrees, which is exactly the temperature that the protein in egg denature. So you get perfectly cooked egg. The downside is when you cook sous vide, you have to wait for a long time for it to reach thermal equilibrium. So cooking chicken breast with a pan, sure I might overcook it, but I'll take it fast enough, it'll be fine. And it usually takes me about 10 minutes to cook. With sous vide, you're looking at like 2 hours.
What's the liquid nitrogen going to do for me?
Liquid nitrogen, when you drop foam or liquid into the nitrogen, it will instantly freeze.
Yeah.
So the outside will be frozen, but inside will still have the same texture. So when you bite into a foam, let's say mango foam, you can buy these easy foamer. You put it into a spoon in liquid nitrogen. The outside will be frozen, but when you put it in your mouth, the outside melts away, and then you have the texture of the foam inside your mouth.
Like a frozen banana.
A foamy frozen banana. And there's just a bunch of video that I have that's kind of cool. If we don't have time, I can skip them. With shameless plug, last slide. There's a Squishy Physics event on Saturday, March 21st. It'll be the Saturday of spring break. So a lot of the material I got here, I stole from the last 3 Squishy Physics. Well, not all of it, but a lot of it. And it's run by my advisor. That's why the shameless plug comes in. So, do we have time to watch any of these videos?
Sure.
Alright. This one is ridiculous. Let's do this one. I don't control YouTube.
Man, I really want to. Is somebody going to win a car tonight?
3 girls.
Was it almond?
Yes. And he adds sugar, and then he's gonna grind them. What he did was he put the thing in a vacuum to suck out all the air in the liquid. Liquid nitrogen.
What was that?
A spoon.
Oh!
He dip it in so that you have a cup of almond cream.
Hey. Yummy, yummy.
The future is cooking.
That's the whole thing I talked about.
Suck on that top shit.
That's my presentation. Hope you guys liked it.
Now, you're going to get together next week with Chris